Hello guys, welcome back to the channel. Today we're going to be discussing a really important topic called generics. So what are generics? Generics in Swift are a way to create a placeholder type that allow us to make the code more flexible and reusable, avoiding code duplication among many other advantages. So you probably already use it without even realize it. So let's see in action some examples. So let's start with a classical example. Imagine you have two numbers and you want to create a function that sum up these two numbers. So it's pretty basic, right? We have the sum function, we receive two integers and return is another integer. Here I'm just omitting the return keyword because we don't need it because it's a one-liner. Alright, so it's pretty straightforward. So we have two numbers, let's say 1 and 2, and when we run it, it's missing the, let's make it without the parameter name to make it easier. So we have two numbers here, and yeah, we sum up to 3. Alright, now imagine that you are on a project and you now need to sum up two doubles. So you create the same function, but now for doubles instead, right? So it works pretty much the same way, but now we receive doubles, right? 1.2 and 3.4, for example, and it works as expected, right? But now imagine you are working with core graphics and we need to sum up two CG floats. So we need to create another function called sum that receives CG floats, right? And return CG float. So you see where I'm going with this? Every time you need to change the type, you need to create another function. So this is not practical. There's a lot of code duplication here. So that's where generics comes in handy. So what we want to do is create a generic sum function that can receive any number and sum up both, right? So how the syntax works? So we put a generic type here. The T is just a convention that you can put here like number, for example, or num or n, doesn't matter. But for convention, I just kept the T. So when we do this and receive a generic type here and pass it to the parameters and the return type, now we can inject here any type, right? But doesn't mean that we can sum any type, right? The developer can insert here a string or a custom type that cannot be summed. So that's where we need to do something else here. There's a thing called type constraint. We need to constrain this type to a certain type of constraint, a certain type that can be summed, right? In this particular case, it's gonna be the numeric protocol. So any type that conforms to the numeric protocol can be summed, right? How I know this? Because all numbers, floats, int, doubles, etc., conforms to the numeric protocol. And the numeric protocol, if we navigate here to the numeric protocol, you see that the numeric protocol itself conforms to another protocol called additive arithmetic. When you navigate to the additive arithmetic, we see here that there's a plus, an addition function. That's why we are able to sum two numbers via protocol. Alright? So that's why the numeric type here works to sum up two numbers. So now if you just, let's say, comment this out and use the sum, now it works with any type, right? We have some, let's say 1.2, 4.5. We have some, let's say, let A CG float, 10.2, let B CG float, 2.3, and we put A, B here would also work. Any of type that conforms to the numeric protocol, now we work within the same function, right? So this makes your function really flexible and you avoided code duplication, right? So there's basically the power of generics. make your code more reusable, all right? But the power of generics is not limited to just functions. You can also create generic types using classes and structs. Let's see this example. I created here a stack struct that receives a generic type, all right? I'm just passing the generic type to an array. So the array here is acting as a stack, all right? So I have here the push function and the pop function, all right? And just the function to print the stack. So when we declare a stack, a new stack, we need to set the type here. So I create a stack of type int that receives the type int. So I can push integers to the stack, all right? So yeah, we have here the stack. We push 1, then 5, then 3. So here's our stack. But let's say I want a stack of doubles. I can also use doubles. So 1.1, 5.1, 3.1. So it's gonna work the same way, but now just with doubles. And it works even with custom types. Let's say we create a custom type here called pancake. I don't know. All right, so I can create a stack of pancakes. All right, I just created here some pancakes. All right, so here create a stack of pancakes. Okay, and if we need to extend this type, we don't need to declare the generic type again. So here when we extend the type, we don't need to do like this, because in this extension Swift can infer the generic type from the stack. Alright, so I can just extend a new capability without need to receive any generic here. Okay, another thing you can do is working with two generic parameters, either on the function or in a specific generic type. So I create this example with two generic types. So I created here a hash map struct that receives a key that conforms to hashable. So this is a type constraint here. All right, and another generic type that which is the value. So I've just named here because it's more intuitive, more descriptive, but it can be like K and V as well. Doesn't matter. All right. So here we use a dictionary to create this generic hash map and some functions to its capabilities. All right. So it works the same way. So we have here a hash map where the key is a string and the value is an int. All right. And the function here set value has first the value and then the key. All right, so this value has this key, right? Int and a string. All right, so yeah, if you want to change here for, let's say, a key int and I don't know, string, let's swap them. So here I need now to pass a string and here and an int. All right, so for key 1, so it works, it should work. Oh, for key, the key is an integer. Okay, and would also work, it works with any generic type here as long as the key conforms to hashable, which means that it's gonna create a unique key for this specific type. So it passed to a hash function. All right, and generics does not stop on custom types. You can also create custom protocols with generic types. So here you have this container protocol, but there's a difference. You see, I cannot do it like this. All right, with the protocol we have a specific keyword to receive the generic type called associated type. So we have this associated type That's the generic type, and we can use it in our functions or variables. We can also create more than one, let's say value, and make this function receive a value. Returns a value. All right, and let's make it just one for now. And when we declare a new type that conforms to this protocol, we need to provide an associated type. So let's say we don't provide here. The compiler will complain saying that you need to conform to this protocol. So the suggestion here is to create a type alias specifying which type is going to be your generic type. In this case, I created a new struct called bag that also receives a generic type. So I just passing through from the bag to the protocol, all right? And now we have here an array of items. That's gonna be the items that's gonna be specified here when we declare the bag, right? So when we declare a bag here, so I declare a bag of strings. I'm just gonna add an apple to the bag, all right? So yeah, we now have a bag with one element apple. Cool. And this is basically what we need to know about generics with protocols. And now I would like to show you some examples in the Swift standard library. So we have an array here is one example, and a dictionary is also an example. As you see here in the documentation, you see that the array is a struct that receives a generic type element. And that's why you can create an array of any elements, because it receives a generic type. Okay, the same thing with the dictionary. So the dictionary is a type that receives two generic types. So as you can see here in the dictionary, we have a key and the value, and the key conforms to hashable. All right, this where clause is another way of declaring a type constraint. All right, so here when we create the numeric here, we could also do it like this: t where t conforms to numeric. Okay, it's the same thing, but I prefer this cleaner version here. All right, another place that you can find examples of generics is with SwiftUI. Let's say we have a simple SwiftUI view here with a vStack with two texts inside. All right, so we have here the view. Let's see the view. So the view is a protocol, and this protocol have an associated type. See, so this associated type called body. All right, and here we have the vStack, for example. Let's navigate to the vStack. The vStacks also receive a generic type called content, where the content conforms to view. So this explains a lot of things in SwiftUI, because this body returns some view, and this vStacks is kind of like we are returning this element that conforms to view. All right. The same thing with the text. Let's see the text. So we have here the text. So here we have an initialization with the string protocol that conforms to the string protocol. So when we initialize a text, we initialize with a generic type that conforms to the string protocol. All right. So this is just the examples I have for today. There's plenty of more examples if you navigate through the documentation. And this is pretty much everything you need to know about generics. Of course, there's more advanced techniques that you can implement, but the basic idea is what I have shown here today. All right, and that's it for today's video. I hope you enjoy. Let me know in the comments if you miss anything about this topic, and also I'm receiving suggestions of next things to talk about here. Give it a like and subscribe, and I'll see you on the next one. Bye bye.